Please do not miss out on this opportunity. I know this is a big day, so please come with the family and have some good time. Okay, so we were on network layer. Sorry, any questions on network layer? It's pretty straightforward. We already have covered this. Like the layer 3 is a device that works on network layer. It has IP addresses for communication, and IP is the heart of our communication system. Okay. And what is an IP address? We studied it already. Transport layer. So the transport layer is basically a layer where the packet is being called as, or data is being called as, segment. The purpose of this layer is basically when a data comes to you, it chops into different pieces. It segmentizes that data. A non-technical example that I generally give for clarity is that you may have a whole roti in front of you, a naan, a garlic naan, or I know how much of you guys are hungry now. Could you digest, chew that particular piece or piece of bread at once? No. What do?
Break it.
Yes, we do break it in pieces. Once those pieces are being made, what we do? We chew them. We do not take all the pieces at once. Same thing does happen technically behind the scenes. So what does the purpose of the transport layer? It takes data and it divides into segments, different pieces. While the network layer delivers data between two individual nodes, the transport layer sorts out which client and server programs are supposed to get the data. Okay? Also remember that the transport layer, mostly TCP and UDP is responsible for ensuring the data gets to the right applications running those nodes. So here are two keywords which I have thrown at you, TCP and UDP. TCP is transmission control protocol. If you want to make notes, that's fine, but in the next slide, there's a complete chart that is over there. So TCP is transmission control protocol. UDP is user datagram protocol. What are the differences? We're going to cover in next 2 minutes. So primarily things are divided over here into two categories. Either it could be TCP based or UDP based. There are two camps. Both protocols uses IP as a layer. So now imagine, again visualization is the key over here. See me over here. So a data is generated by my computer and it's in the form of bits. Now it has to go onto the segment. Exactly, frames, because it is going to become on data link layer. It will come onto a data link layer. So the protocols get involved in it. So it's most likely going to be an Ethernet connection. Okay, so now it becomes frame. Now it would have an IP header in front of it, because it's going to on layer 3. And now the same data would have another header in front of it. So it started with one piece, then became a header, then it became a header, then it became a header. The fourth one, it could either be a TCP or a UDP based. But IP is the backbone. IP is gonna dictate how things will be working. Like IP is the steering wheel, you could say. Okay? Okay. Two terms which I mentioned, that was TCP and UDP. But before I go into this? Let me give you an example. Okay. So, could you give me a non-technical example where you could wait? A non-technical example where you can't wait? Or I'll rephrase my question. A non-technical example where you could have a delay, and that's fine with you. A non-technical example where no, there shouldn't be any delay. It should be right away. Okay, let's try to make it a little technical. For example, if I'll send an email, could I will I be okay if I would have a delay of 5 seconds or 10 seconds? Could I bear that delay?
Yes.
Yeah, that's fine. It's just an email. It would have some data. It may have an attachment. That's fine if the receiver receives that same information in 10 seconds. But as long as it's being delivered properly, it is reaching over there, the receiver has received it and acknowledged it, that's perfect. A non-technical example could be a Zelle transaction. If I am sending that money, could that wait 2 days? No. You will be in a continuous mess. Your brain would be processing that information. But if you'll do a scan a check, you needed to make sure that it should be going to right account and everything, and that might get some delay. So a Zelle transaction is very quick, Venmo, all those things. You should expect them to have received right now. If you're not expecting this, probably someone else had the money. Alright, someone else have gotten. But again, it's not an exact example. I'm just giving you like a non-technical example. So an email, I'm okay with a delay of like 5 seconds, 10 seconds, even a minute is okay, fine. But what about voice call? If I call you and I do, hey, hello, how are you doing, Razi? And if I don't receive a response in the next 5 seconds, we can't do our communications. Yeah. It would be like a complete mess in communications. Like I probably would have said 3 times hi, hello to him. He may have responded back to all those things, but we were in a continuous non-proper communication with each other. So exactly same in computer networks and in IT or in data networks. There are some things that we could expect delays, but we don't need them to go where we wanted them to send the information. They should be authenticated. They should have a reliability mechanism. And if it's not properly being delivered, do retransmissions. Make sure that they receive that proper information. And then there are some applications, it's like, I did my job. If the receiver receives it, that's fine. If it's not receiving, that's not an issue. So both of them are being an example of our networks, and here things will become a little interesting. So as I told you, there could be sort of 2 camps. One is TCP camp and other is UDP camp. TCP is transmission control protocol, UDP is user data graph protocol. TCP connections are connection oriented. What does connection oriented means? Before I send a data to you, I would like to make a communication with you. And what that communication most likely be? It could be a server client model. I wanted you to make sure that, hey, will you be available? Will you be engaging some resources with me? It's again like, before I come, a non-technical example would be that before I leave from my house to meet my friend, I would call him and check his availability. If he is available, then I'll go, because I don't want to waste my time. I don't want to waste his time. I don't want to jeopardize this relation. I don't want both of us be in an uncomfortable position. I am spending time as he also, so I want to make sure that none of the resources get and lost in that communication. So connection oriented example could be a non-technical example which I have mentioned. What is a connectionless example in this case? I just go over there and knocked on his door and hey, I'm here. So he may be able to respond back to me, he may not. So the problem with connection oriented and connectionless applications would be that with connection oriented, you do need some more time. You most probably may need more resources and more time, but they are reliable in the nature. When in connectionless, they might not be reliable, they may not be resourceful, but it gets the job done right. So VoIP, voice over IP, is an example of this. Audio video streaming would be this. Now, I think you might have a clear cut idea in your mind. Now, I would give you a task as a homework. Take 5 applications, those are TCP based. 5 applications, those are UDP based. Next time, I would ask you a question. And you guys have to give some examples for that as well. Okay. All right, we already discussed reliability. So TCP is reliable, UDP is sort of non-reliable. वैसे डॉलर्स reliable है, वैसे TCP भी reliable. इसलिए reliable. यहाँ पे वो UDP होगी. Okay. So next question. Next thing. Error handling. Since connection oriented things, TCP is connection oriented, it checks, it makes sure that the receiver is going to receive it, that information is available, he has engaged his resources as well. So error handling could also be happening. So for instance, if I am sending 10 packets and I am a TCP based application, first packet goes over there, I may need that acknowledgement that, hey, I did receive that thing. So when I'm sending 10 packets, I am expecting a confirmation back from them. If they do send me confirmation for 9 packets, but 1 packet is not confirmed, then I would try to retransmit that information again. So the retransmission mechanism is built in TCP. On the other hand side, UDP, it is not. By default, it's not. Okay. Priority for TCP is reliability. Like, oh, I'm fine with it that as long as that email is going to the right person, it's fine. It could take a minute also for me, that's fine. But for speediness, speedy communication, like if you, let's suppose you're watching an NFL match or a basketball game or any other thing, would you want reliability that no, I want this throw to be gone over there and it should be reliable? I could expect a delay of like 5-7 minutes. No. You want things to see them in live, in person. So like audio video streaming, voice over IP, and some other applications, DNS, those things are covered under UDP. Yes.
HTTP and FTP, this is a different, I think.
Yes.
HTTP, we know that, right? FTP?
FTP is file transfer protocol. File transfer protocol. So when you are doing file transfers, this is a technology or application that you may use at the back end. So what also happens is that understand this also, that when a server is providing you a service, it most likely would have other features also called in behind the scenes as well. So to you, you may look that, oh, okay, one piece of the website is working, but behind the scenes there are some other things that are also working as well. So FTP is one of an example, file transfer protocols. So when you will be transferring data from one end to another end, most likely you are going to use FTP. But there are some other versions as well, secure FTP as well, SFTP, SCCP. Those are also protocols that could be used for file transfer. But most common one is FTP. Same as HTTP. There are secure versions, HTTPS, which we covered last time. So this is an example of TCP. A very good example of UDP is DNS, domain naming system. This is also a part of your homework. DNS, domain name system. DNS, naming system. Naming system. DHCP. Last time we discussed a little bit about it. CP. D, dynamic. H, host. C, configuration. P, protocol. Dynamic, host, configuration, protocol. DHCP. Another term, NTP,
Dynamic host what?
configuration protocol. NTP, network time protocol. Do a little research on these protocols. I am going to cover them in next session. If you'll come prepared by reading them, and again, like I'm not expecting that you should know everything about it, but at least get an idea what these protocols are. We are going to cover them in our next session, but this is very, very interesting.
When you give DNS, TTPC,
DHCP,
DHCP, dynamic host configuration protocol, and NTP.
network time protocol. NTP is also a very useful protocol. Why it's useful? Just giving you one-liner answer. We could have hundreds and thousands of devices on our network, and they could all have a different time on it. We wanted to make sure that all of the time synchronization for the devices should be same, identical, so that whatever we push, whatever we receive data from them, they should all be on same time. They should all be synchronized. A question. Does this sounds to be a TCP based kind like of a thing or a UDP based kind like of a thing?
TCP.
It's your homework. DNS, what is DNS? Domain naming system. It translates IP into name into IP with a different flavor onto it. But you could say, like, if I type google.com, and I showed this you in real time, that we typed google.com or facebook.com or apple.com, it gave us the IP address. So behind the scenes, what was working? DNS was working. Should this be a TCP based or a UDP based? It's a homework for you guys. You guys have to investigate this. DHCP. There's one way of assigning an IP address, which is manually. But could you assign IP to 10 devices in your network? Yeah, most likely. Could you assign this to 50 devices? Yeah, it may take a day. Could you assign this whenever a device connects on your network and you have to configure IP address manually? Most likely not. If you're out of shift, how you could do? But if you configure a protocol or a server in such a way that whenever a user connects onto the network, it gets its IP, it should be unique on that local area network, that would be something which takes a lot of, I would say, like operational power out of you, a lot of manpower out of that. So DHCP is a very known, useful protocol that should be on your network. Does DHCP needs to be TCP, or does it belongs from the clan of UDP? Homework for you guys. For HTTP and FTP, I can't give you because it's in the slide, but I would suggest you to have a look on these protocols as well. Any question? I think things should be pretty clear now. It starts to make sense. Application layer, finally the fifth layer is known as the application layer. There are lots of different protocols at this layer, and as you might have guessed from the name, they are application specific. Protocols used to allow to browse the web or send and receive email, or some common ones like file transfers, time synchronization, name resolution, assigning IP addresses. These are all some sort of an applications.
Layer 5 is not application layer, it is session layer, no?
This is OSI model. Not OSI model, this is TCP IP model.
Okay, it's, okay.
So in other words, what I could say also is that, and here it's becoming a little interesting. I'm not sure how much you guys would gonna understand this, but I'm trying to summarize my experience and a lot of book knowledge into a few sentences. So this is very important. A protocol, you could say, is kind like of a person or someone that you have hired for to do work on behalf of you. DHCP is a protocol, is a kind like of your servant. And what's the purpose of DHCP server is that it assigns IP addresses whoever is requesting. It's his job, it's his duty which he has to do. Same as NTP server, time synchronization he has to do. You could say it's a kind like of a server, like your servant who's serving you. By the way, why we use the term server? Because it's serving some services. Okay. Same as other protocols. For applications, understand this as something that if something is on layer 4, it's most likely going to be either TCP or UDP, which I have told. When something qualifies to go up until layer 4, it goes up to application layer. It could be either OSI reference model or it could be TCP IP. So it's like if someone has qualified for layer 4, it has reachability to up above all layers. If something is pure layer 3, then it cannot go up until up to layer 4, 5, 6, 7, or in this case layer 5. So if someone who's already at layer 4, who is TCP or either UDP, it is an application. You may not understand this term, but now when you review this, you may understand this. So anything that is on application layer, it has association to all backend layers, and it has an application port number to it. Application port number means that they are being identified with a unique number. What is an application port number? I'll come back to later on when I'll be discussing all these protocols in detail. But for a quick reference, or the short answer would be that Whenever I do see port number 53 in my network, it means this most likely be traffic of DNS. If I do see port 23, it would most likely be telnet. If it's port 22 on my network, it is most likely be SSH. So the protocols that I have discussed with you or covered with you, they would have a port number. It's a kind like a roll number. Again, I'm teaching, giving this information on a very high level. We'll cover these in details. So if I'm a security person and I want to block telnet, which we most likely will gonna do, I would configure it in such a way that I block all communications on port 23. That I do not want 23 port to be seen on my network. So whenever traffic is being generated and a firewall processes this traffic, and if it sees that it has port 23 to it, it will just gonna be blocking that traffic. Why it's important? Imagine, when I block TCP, I block everything. When I block UDP, I'm going to block everything. But I want my network to be running in a safe and sound way where I want TCP to be there, but I do want telnet to be get blocked. So we do not have a choice to block entire TCP or entire UDP, but what we could block, allow access based on these application numbers, and every application has port numbers to it. So that is why port numbers are of importance. Applications are of importance. There could be a case where I do not want file transfers to be running within a network segment. So I'll just block FTP over there because there is no need. It could be a security threat. It could be a company-based policy that I have to implement. There could be a network-based policy that we do not want any telnet communication on our network. So what are we going to do? We're going to block everything? No. No. If I block TCP, I would lose all other features of it. So what I'll do, that TCP is still there, TCP should have to be the part, UDP should have to be the part. I'll just allow or block those applications, which is my requirement. And that can be done on the basis of port numbers or applications. Okay? This is a conversation that could go many days, not hours. And this is what I do for my living. So the short answer to you is that applications are there to serve you something, and the protocols are being used. You could control them by default. In your operating system, these things come installed. Like you do not have to do anything in Windows or in Mac to enable to set up the entire DHCP thing or entire DNS process. No, they are the part of your operating system. When you install Windows, you are installing DNS, you are installing the functionality of IP address, you are installing all the things that we have discussed. MAC addresses, they all come together. But it depends on you, whatever you want to enable or whatever you want to disable. When you bought a phone, have you asked that, no, I want 2 MAC addresses on my iPhone? Apple will gonna most likely refuse you to give you a phone. No, you just bought the phone. It already had operating system. It already had DHCP settings. It already has browsers in it, but whatever functionality extra you want, you just download that application, and that application gives you that functionality. So when you download an application, the application gets connected with the operating system, and that is how behind the scenes things will gonna happen. I know it may be a little difficult to understand at this point, but maybe sometime later you would understand this thing. Any question? Well, these were the most difficult conversations. Now things are going to be little easier. I'm just gonna read through the slides and just explain some stuff to you. Any questions so far? If not, we can move further. So, cables. As I told you that this course is like network fundamentals, network communication fundamentals, or as well as data center technologies or data center related stuff, equipment we are also going to cover. So this first slide is related to cables. Generally, there are two types of cables that you would see or you will encounter in a data center or in a office network. So I don't have to explain you what are cable used for. Cable has their functionality, it is used for connectivity. So a cable could either be a copper cable or it could be a fiber cable. Example of a copper cable, last time I have showed it to you. An example of fiber cable, I forgot to bring my Pandora's box with me today. So that one has fiber cables. Next time I'm going to bring it to you, but I already have showed you fiber cables. If I would see any over here, I'll show you. By the way, these things we are going to go in our data center today, and I'll try to see what I could explain it to you. Okay. So on one side you could see fiber, and on the other side you could see copper. So cables, copper cables are the most commonly used form of networking cables. You may have already seen this. I'm going to show it to you how they are connected today. They are made up of multiple pairs of copper wires inside a plastic insulator. So in a common Ethernet cable, copper cable, and in our case we are taking example of Ethernet cable. An Ethernet cable would primarily have 4 pairs in it, and they are pairs, so it becomes like 8 wires in it. Okay? So they are made up of multiple pairs of copper wires inside a plastic insulator. Here is an example of 2 cables, UTP, STP. One is unshielded twisted pair, the other one is shielded twisted pair. You could see there's like a shield on STP, on other you won't see it. Why they are being used, where they should be used, I'm going to cover this in a later piece. But regardless of their difference, you would see 4 pairs. One is green and white green, coming from UTP. Green, the one end of that cable is, in a pair, is complete green and the other is white green. Second is brown, so complete brown and white brown. Third one is orange and white orange. Fourth one is blue and white blue. Again, this is not something that is of great importance, and you should spend most of the time over here. Probably in your first job you may need to know this, but most likely not later on. So I'm not expecting you to 100% memorize these things. Some of the concepts are important, which I'm going to tell you. So they are in 4 pairs. Okay. So these are physical cables. The data that travels on these cables will be in electrical signals, zeros and ones. These are voltage controlled because it's a physical cable. The most common types of twisted pair cables are, you may have already heard of it, CAT, CAT5, CAT6. CAT means category. So CAT5, what is the difference between these cables? So CAT5s are older cables. It would have like 10 megabits per second to 100 megabits per second speed. Category 5, CAT5E is the least one that is now widely being used. It could support up to 1 gig of traffic. And category 6 is a cable that could support 10 gigabits per second. It's like better quality, enhanced cable materials that are being used, newer standards, but that's why they are more expensive. So most likely you would not see Cat 5. You may encounter with Cat 5e or Cat 6. Okay. So while you are working, I would actually expect to have at least 5e cables in an environment if I will be working. But Cat 6 is what I see now every day that is being used. Okay. For example, if I do have two switches and I want to connect them with 10 gig port and both ends have Ethernet, could I use Cat 5?
No.
I can use, but the limitation of the cable drops down our performance. So it is not like that this device should only support Cat 6 or that. Yes, there could be a possibility, but most likely when you connect a cable, you would have that information readily available to you. Okay. Any question on this? UTP unshielded twisted pair, STP shielded twisted pair. Why we have to use one or another? Any question?
For safety purposes?
Yes, it's a good question, but safety from whom?
Animals, like they don't eat the wire or something.
Eaten by any animal or anything like that?
Yeah.
That could be a possibility as well.
Accident corrosion.
Yes, but these are not the answers that I was looking for. Yes.
Protect from interference.
Excellent. This is what I was thinking. So, the shielded and unshielded, why we have to use? So, imagine if these cables are being used in an environment, if I run them through, there could be an electromagnetic interference. There could be electrical interference. So that could degrade or deperform or impact the performance of that cable. So in order to protect them from these electromagnetic interferences, we'll use shielded part to it. So it's kind of like of an insulator. It could also be weather insulator as well. It could protect with the heat as well. So these are some of the reasons. So if I'll be using outdoor or near to electrical stuff, I would most likely go with the option of STP, shielded. But if the devices are right here, I don't see any negative interference in between, I would just use the unshielded one. And another thing is that unshielded one, I could bend it easily. The last time I brought the cable, that was unshielded. That is why it was in a row. For shielded, it could bend a little bit, not more than it could be. Again, like, these are just to know kind like things. You may not expect this much more information, but whatever I have just told you, it's enough. It's sufficient for you. नेटवर्क की जिंदगी और मौत इस पे नहीं चल रही. You could place a shielded where unshielded was required or other way around. That would still be like it's not the end of the world if we use one cable or another. Same as with category 5 or E. But the point is that if you want to enhance the performance, if you don't want degradation or service disruptions, or if you want full output, then go with the standards. Any questions? Straightforward. Fiber optics, mostly known as fiber optics. So the second connectivity method or the cables that you would most likely be able to see are fiber optics or fiber cables in short. Now the difference between a fiber cable and an Ethernet cable is that the fiber cable is made of glass mirrors, and they are very the strand over is very thin. So over here, it is not electrical signals. it is being delivered within light. So the data literally travels here over the speed of light. It is physical, but it's in a different physical state. I would bring the next time these cables, and I would like to tone them, and I would like to show you. These are the cables which are very fragile as well, because it's made up of mirror. So we can't bend them too much. That's the downside of it. But the performance wise, it's more suitable. That is why most likely you have heard of it, that the fiber is broken within the sea, or if you are connecting to different, you may have heard of dark fiber, or you may have heard of it that the fiber is broken from ISP side. Why? Because it carries much more data. Because it is the speed of light, it travels much more greater way. You could dig up and install the fiber over there as well. It carries more data, it's more speedy, but it's little bit fragile as well. So whenever there are high speeds of data are involved, we generally prefer them to connect on fiber ports via fiber cables.
But why? They're so fragile and it might have cost like much more than the regular ones.
But we cannot compromise on speed. Another thing is that with fibers, there is a limitation that can be used. There is a limitation which you have already seen with Cat 5, Cat 6. There are some other categories as well, Cat 7 as well. But those are electrical signals. We do expect some sort of a degradation up to some distance. With light, and this is the beauty of light, we do not expect to have degradation. There could be interferences with Ethernet ports, but there is much less interference as compared to with these ports, with the fibers. So high-speed connections are mostly based off fiber. I know it's little going to be boring, but these are the things that I cannot try to make them spiced up for you. You just have to take it. So fiber cable contains individual optical fibers, which are tiny tubes made from glass about the width of a human hair. These tubes of glass can transport beams of light. Another thing is that because this beam of light, the light is involved, the data could travel at the speed of light as well, theoretically. With electrical signals, yes, it cannot reach up to speed of light. Like nothing can reach to the speed of light, like if we talk around. Unlike copper, which uses electrical voltage, fiber cables uses pulses of light to represent the ones and zeros of the underlying data. The data is going to be same. It is just translated into the light. Whereas on copper side, it's being translated into electrical signals. Okay. Fiber is even sometimes used specifically in environments where there is a lot of electromagnetic interference from outside sources, because this can impact data being sent across copper pipe. As I've told you, like there's much chance of interference with copper because it's electrical and magnetic fields. With speed of light, there's a lesser chance that it would get disrupted. Fiber cables can generally transport data quicker than copper cables, but they are much more expensive and fragile. As they say, Husn ho to nazakat aahi gar. So this is the downside of using fiber. It's expensive, but yeah, we cannot compromise on speed. Fiber can also transport data over much longer distances than copper without suffering potential data loss. That is where it comes important. Okay. Again, I do not want you guys to remember each piece of it. Just take the concept of it. Here are some examples of shapes of fiber cables. The most common that you would see or that you would use is the LC converter, LC side. The second most you could see would be the SC side.
What is LC?
If you'll ask me an abbreviation, unfortunately I don't remember. But I'll try to see. LC converter or SC converter. Interestingly, we could have a cable that could have both sides as LC. One side could be LC and other could be SC. One side could be FC and other could be ST. There could be multiple combinations there. So it depends what we are using and what is our use case. It depends on the SFP module as well. What is an SFP module? I'll show it to you.
I have a question. I'm seeing the upper ones, I believe, in my TV.
It's not that exactly, but yes, in some equipment they are being used.
Okay.
They are mostly or widely being used in telecommunications, and they were also being seen somewhere where the ISPs terminate their data as well. So the most commonly used ones are LC and SC, and LC is being used. These are some of the descriptions. Again, I just did a Google research. Not even Google, I think this is generated from ChatGPT screenshot. So do not get surprised if you search this thing. You could see where these are being used. So LCs are used in data centers. They are used for telecommunication networks. These are high density installations. If you do go and see a little bit onto it, the LC is the most least consumption it will take in terms of space. So if I had to connect 48 ports, let's assume, it requires lesser space. If I use SC on the other hand side, it is a bigger unit than this. So most likely I could not use 48 ports for this connectivity. So what I would choose, I would use the smallest factor, which is the LC one. That is why it's more popular. Because the density, if I use any other cable, it would need more space. It's simple as this. You guys also have a table, I also have a table. If all of you gets this similar size of this table, we need more space, density. But the same table could be used anywhere because we could accommodate more of these desks. Same as the case over here. Any question? For all these other types, FC, ST, SC, everything is written over here. Trust me, this was the first time I know that, oh, it's 1.25 millimeter diameter and the other is 2.5 millimeter. It's not important for me. It may be important for someone else who's doing all this stuff. It may be important for your first job if you're doing like this physical transfers or physical translation, but getting them now onto this level, I do not expect this to. If you needed this to learn, just quickly do a Google research, even at your job. So FC and SC connectors, they can be used in industrial applications or backbone cabling. Okay. Any question? Are you guys tired today, or are you guys like understanding everything? Or is it like boring? Because you are not that interactive with it. Or is it a combination, mixture of everything?
I took my medication, that's why I'm a bit low.
Oh,
So
no.
I don't know what it is.
Okay, next thing is media converter. Okay, media converter. So for media converter, this could be a device most likely you would see in a data center. Or maybe at your home as well. So imagine I have a switch, I have two switches. Again, visualize this. One switch has all fiber ports, and other switch has all Ethernet ports. What should I do? Should I cut both of them in half and mix them up? No, most likely not. If I can't do that, what I can do? I can do this thing. Media converter. So what is the purpose of the media converter?
It will convert those ones to the fiber ones.
Exactly. The purpose of media converter is to convert the media. Because Ethernet is a media as well as fiber is also media. So this device, this tiny teeny little device, could be used as a media converter. Well, it's not ideal to have these media converters because the issue would be that if I do have 48 port switch on both sides, I would need these 48 ports.
I have a question. So, is HDMI as an example?
Sorry?
Is HDMI as an example?
That is a different media converter. These are media converters basically for telecommunication or
Okay.
communication, IT communication network. So what can I do is that, for example, I do need an uplink. Uplink means that I do need to connect two switches with each other. I would put in this device. So the fiber port of the switch, one end is in the switch, the other end goes into the SFP side, small factor. And the other switch who has Ethernet connectivity, I'll connect one port over there. So there would be technically two different cables, but this media converter is the translator in between. It is converting, it's doing the magic of converting electrical signals into light and vice versa. Again, it's not ideally to have it, but it's fine, we could use it if we do need to. Why this could be an importance, of an importance. Imagine you do have two switches. One was either purely Ethernet and other was purely a fiber, and one switch died. The spare one you do have is not of the same kind, it's a different kind. So now you use this one to at least have a connection in between. Like, it's a kind like of a jugaad, or you could say like workaround that you have to make on your network, if this is the case.
Is it usually small in size?
Yes, it's
But I
like,
really have seen that.
like I can have two in my hand in fact. There are bigger ones as well. So this is one phase of media converter. This is another one. The Ethernet side is same, but the other side is different.
Okay, because of that 4 types of ports?
Yes, because we do have different types of ports, we could use different types of media converters as well. So before you buy, before you purchase, just see which cable you want to convert with which one. And they are not expensive, I guess like $25, $30, $40 I have seen this on eBay. This example is a very good one. So that brocade switch is a fiber switch. It has SFPs connected onto it. Okay. Those SFPs would have one end of fiber cable and the other goes on to fiber media converter. Well, on the other hand side where the Cisco switch is on Ethernet based. One end of the switch of Ethernet goes into the media converter. Now this picture gives you a complete idea. Okay? Alright. This picture on my right hand side at the corner, this is a GBIC. This is an SFP module, but I can connect it in a modular switch, and I can make a fiber port into a Giga Ethernet port as well. I think I have brought this one in my first lecture, but I'll bring this one in the next lecture as well. So either I could use that media converter above there, or what I could have also done is that, for instance, I did not have fiber media converter with me. I could have taken up this one and could have inserted like this way, and both these switches could be connected via Ethernet cable. This is a little expensive, but it has much more better performance. This one takes less consumption or space as well, hardware density. Why? Because I do have to power on that device as well. That device needs power as well. This is a pure hardware module. So instead of using that device, I could just take this up, could have inserted here, and both these switches could have been connected with each other. So again, there are more ways of doing the same thing. It's just which one is better or suitable for you guys. Any questions? Ethernet port. You guys are already familiar with the Ethernet port. You may already have an Ethernet port on your laptops. On Ethernet, it's an interesting thing to know. When you do connect Ethernet port and it's blinking up, the light signals could also give some idea behind the scenes as well. So there is a link light on the left hand side and there is an activity LED on the right hand side. So whenever we do connect and if it's working, the link light would flash up. But if the data is being transferred, the activity light will go on flash. So there could be a possibility you are doing a layer 1 troubleshooting, you did connect a cable, the light didn't came up. So that means that either the port is shut down or the port is not up, the cable might have been damaged, or it could not be a correct cable, or it could be something else. Like now you will start doing the troubleshooting, but the physical piece you already have checked it. Okay. Cable properly connected to two devices that are both powered on. Last time, if you do remember, as soon as I have plugged in it, it started to have this thing. Okay. Next thing, activity light. Activity light would flash when data actively transmitted across the cable. Okay. Yes.
All Ethernet ports have to have these, or is it possible that, I mean, like, do all Ethernet ports have to have these lights? Or
Not
does it depend on
necessarily.
the device?
Not necessarily. It's again just one way of seeing things. It could be a possibility that communication is happening but the lights are not indicating. But most of the times you'll see these things working like this. Okay? Power over Ethernet. Is this a new term to you guys? So, interesting. Oh, I didn't know that we would have power over Ethernet today. So, imagine we have this camera in this room with us. This is the Ethernet cable connected onto it. This is power cable for the fan, so it has no connection with it. Okay. Do you see any other cable that is connected onto this device other than this black one? No. So how does this device basically running on?
It has to be powered through this.
Power over.
Yes, power over Ethernet. So the Ethernet is used to deliver data communication. And there were 8 cables, 4 pairs that were being used. Fortunately or unfortunately, you could say that, definitely it's fortunately, only 2 pairs were required to send and receive the data. The other 2 pairs were idle, they were just doing nothing. So what they have come up with the technology, they say that, okay, the 2 pairs which are already transmitting and receiving the data, that's fine. But let's use and utilize these cables which are not doing anything. They are nickel 2. Let's just put them on to work. So what they put them on to work, they say that, okay, let's deliver power to them as well. So power over Ethernet means that the same device, the same cable that is used for communication, it's also delivering you power. But this is a device specification as well. The switch can generate that power and send it to this device. Okay? So what is power over Ethernet? Power over Ethernet delivers power and data over a single Ethernet cable. So imagine you have 20 cameras in this building. We do need 12 power sockets as well. If it's a 100 camera facility, we do need 100 power sockets. And just imagine that not everywhere you could have a socket. And then you have to manage that one as well. Right? So, what we are going to do, we already have Ethernet connectivities with us. We already have Ethernet connectivities. So with Ethernet connectivities, let's just deliver power from the same cable. Because one way or another, we do need Ethernet cable. Even though if we'll have a power socket over there, we would still need Ethernet cable to travel the data, to transfer the data. So by this, you could save up your power cost as well. You could save manageability as well. And it looks much more nicer. It's much more efficient. Previously, you had to manage 2 things, the Ethernet cable separately and the power cable separately. Now the operational overhead is less. You just have to manage the Ethernet cable physically. Isn't it smart?
Yeah.
So there are some devices, like IP camera is one of an example of power over Ethernet operational. IP phones is one example. Some IoT devices are also an example. So it's a standard. It is not something that is proprietary. It is not vendor specific, it's vendor neutral. It is not that some company has made this. So that is the plus point of it. Second thing, commonly used for devices like IP phones, wireless access points, and IP cameras. Simplifies the installation by eliminating the need for separate power cables. It enables remote power management and monitoring of connecting devices. Pretty straightforward. Any question? Yes.
Typically, it's for smaller devices, like you're saying, cameras.
Yes.
Phones. Nothing too big.
Nothing too big, yeah. Yeah, we cannot power like routers or switches, firewalls. There are a few devices which we could do, but definitely there's little power that could be gone because of physical and hardware limitations of hardware. Yeah, this is a slide. So generally we use T568B as representation. This is just like a representation way of saying this. You could say like a standard that they have made. So cable 1 and 2 are used for transmission plus and transmission negative. Cable 6, 5 and 6 are being used, sorry, cable 3
3 and 6.
3 and 6, they are being used for RS, meaning receiving positive and receiving negative, while other 4 ports, 4, 5 and 7 are being used as DC connections for power distribution. Okay? Next thing, patch panels. I know it's a little boring. It was boring for me as well. But just, you should know these terms. No one expects you to be solid or like PhD to do in these things. If someone asks you that what is power over Ethernet, you should be able to explain it. You do not have to remember that on these ports this is working and on these ports, these cables, this thing may be working. No, you just need to know the concept. Same as with TCP/IP model. No one wants you to be master in it. You just need to understand the functionality. So, yes, was there any question? Okay, patch panels. So, I have a question for you guys. For instance, if I do have a router here in this area, and I do need to connect a device physically that is over other room, what is the smartest way of doing this? No, with a cable.
It should be here. Close by.
But if it can't be, then this device needs to stay here, that device needs to stay over there. Okay, what if I have to move or manage this device? I have to re-cable that entire cable.
Yeah.
You see a limitation with it. What patch panel means or patch panel does is that I'll put a patch panel over here and a patch panel over there. Behind the scenes within the building, I would do all the cabling with each other. And over here, what I would do is that I would just take my device and plug a 1 feet cable to this patch panel and a 1 feet cable to that patch panel. So by that, what will gonna happen, all the backend cabling, plus it's hidden from us. Second, it looks much more better. Third, we do not have to go with all these things for other 40 cables. Of which part? From the start?
The patch panel.
Okay, let me show it to you. These are some of the examples.
I was gonna say like, well, back in the day,
Landline.
yeah, landline, kind of like that, right?
Exactly.
Or the Wi-Fi, like, in every room, there's like a port for the internet, so like, in the old days, you put your Ethernet cable through there.
Yes, most likely in your houses you have seen RJ11 or RJ45 cables.
Yeah.
This is one way. This was like one port patch panel. And actually you could see much more patch panels. And this is the same slide, Razi, that you were mentioning. So the behind the scenes work has already been done. Now you do not have to connect a 40 feet or 50 feet or 100 feet cable. You just have to connect a 1 meter cable or a 1 feet cable directly. Now it would have a direct connectivity to whatever the device over there is. It is.
Like, I remember, like, at home, we used to have, the router in the basement, and that was connected to the, one of these patch panels down there, and then from there, we go up the house, which would also connect to the router.
Yes.
Whatever the needs
So-
to control.
And the same thing I'm experiencing back at my home as well, because my Wi-Fi performance is not that great. I could not play my games if they get disconnected. Work is fine, I could do work anywhere, but I can't play my games, so that's the suffering part of it. So now what I have to do in my home, I do have to make a patch panel over here in the sockets, because I cannot run 100 feet or a 250 feet cable. What I have to do is that, and so maybe this is very important. I already have a router at home, and again, this is my home setup, so now I am explaining it to you. My setup is already there. What I do need to do that I have to create some sort of a patch panel, run all the cables behind the scenes, like from the basement or from the drive walls and everywhere else, and make that connection available onto this socket. So most likely, the other end of this, assume this is the living room. The other end of this patch panel would be connected to a router. That router most likely would be in a basement or in a corner room or in a different floor. So all that back end stuff is physically, that would be done by someone who's professional onto it. But this piece is called a patch panel. By connecting onto this port, and the other end is over here, I am most likely to get connected physically, not wirelessly, physically to that port on that other side of the router.
Okay, so that's why we have like these usually installed in almost like every.
Yes.
Okay.
That is why it's being used. So if this is an issue at my home for my gaming setup, just imagine how could this be a big issue in the offices? And this is where I'm gonna pitch you guys a business model, a business idea. That is why I'm saying it's an important thing for you and someone who wants to do business as well. I would do anything to pay anyone who could do this stuff for me, like $300, $400, $500 if they could do this stuff at my home. Just imagine how could this go up a scale if you do this for small businesses, if you do this for houses and the home, or even in the community as well. This could be a good business model that you guys could do. अच्छा वाला business आप लोग run कर सकते हैं. And we could have a discussion on this as well, and I could give you some tips, tricks, and all this stuff as well. So this could be a side job, a side gig, or a weekend kind like of an activity that you guys could do, and you could earn money as well. Or if you could hire someone to do this, technically you will oversaw this. You are the manager, you are the business owner, and someone else that could do, you could have a team of it and do this on a bigger scale. I know someone who does this for all the time, and it is their job to do this stuff. Like I'm got quoted around like $600, but I know that this could be done in like $200 to $300 or $400. So this is a business that
Feeding the ports.
Working them in such a way that putting up patch panels and run these cables behind the scenes. And there are some tools that we could use to do this, and you'll see them in coming in the next few slides. So there are like crimpers that could be used. There are some testing materials. There are some devices. I think we do have some devices over here as well. Let me check with them. Like you could check the ends of both connectivity as well. Like for instance, if someone has done this thing, but I'm not seeing the performance, but I could do that. I'll connect one end of the device on this side and the other end of this device as well, and they could give us the performance results that okay, this cable is good or not. So you could improve your own performance from these things as well. So it could be a good business model as well. Maybe there's someone who could be the next Elon Musk from this room. Any question?
Well, in homes, isn't this on the decline?
On?
In like homes, using patch panels.
I would give the same statement what I have mentioned this previously, that behind every wireless technology, there is always going to be some wire technology. Yes, I know a solution exists that is called Eero, but when I'm playing video games, I want them at that level that I do not want a frame drop. Because I'm playing fighting games, I play Street Fighter and I could not have that frame drop with me. In wireless, there could be some ways that the performance can deviate. So wireless technology, yes, it's widely being used, I'm all for it, but behind every wireless technology, there's a wire technology. So I would like to configure this as this. Any further question? Oh, this is one of an example. So imagine these are in two different rooms or on two different floors. What we could do is that we just need a 1 meter length or a 1 feet length cable. Take them from the switch, connect this onto the patch panel, same from there. And all these behind the scenes cable connectivity that are pre-terminated one. You do not have to do this. Someone else have already done this for you. But this thing you could manage on your own. Like if you'll ask me to change these 5 cables on a daily basis, I could do that easily. But if you'll ask me to change these behind the scene cables, I cannot do that. So that is kind of like even one-time job. This is you could do easily. I'm not super technical in that stuff. I could not go into crawl spaces and other stuff and behind the drywalls and everything. That is someone else's duty. They would already do this for you and then it's done. Now, the ownership piece for me isn't just between this area. If that pre-termination would not have happened, the whole point of terminate, like this is my whole ownership. I would have to own all the piece of it. This entire picture would have been under my ownership. So by that cable termination patch panel, I just reduced my ownership piece from the switch to the patch panel, not behind the scenes. But if someone who's handy, who knows how things work, they could do that pre-termination piece or part to it. And that is where I would say like you could have a business model. But again, it's not for everyone. Any question? Yeah, this was a little interesting because there was a business model associated with it. So money matters, I believe. Okay. Tools. Yes, this is also going to be something interesting. You may have seen some of these tools. So the first tool is crimper. A crimper is a handheld tool that looks like a set of pliers. It is used to squeeze down or crimp wires. So if it's shielded, do not get hurt. Use these tools to play around with this. And for all these tools, whatever I come in, if I start to demonstrate them, I do need 8 hours because how crimper is being used, how cable stripper is being used, it's like 15 to 20 minutes of kind like a demonstration. I would suggest you and urge you to go to YouTube and just type or even Google that how to use crimper, how to use this tool, how to use this tool. You just have to watch 2 to 3 videos of it. And by the time you watch them, you'll know how to use them. Once you know how to use them, you could open your business or rent it out for your first activity or something. And these tools are not that expensive, like probably in a couple of hundreds you could have these tools. Just play around with them and advertise yourself. Yes?
And these tools you would use in bench press shop or not really?
Most likely not. The answer would be why. The reason would be that in a data center, you do not have to make a cable. If you do have to make a cable, you may have to replace like at least a couple of cables a day, or it could be potentially when you're doing a data center migration, you would need 200 to 300 cables. So those cables come up pre-built. You do not have to build them. If you do need to make a 1 cable or 2 cable, or you're working for a small office or home office kind of a setup where they are just paying you one-time job, if you'll buy a pre-built cable, it would be costly. But if you'll make this cable on your own, you just have to buy the bundle, and it could be like $1,000, feet bundle or it could be 10,000 feet bundle.
Yeah.
Now, depending on your measurements, you could customize that cable right away. Like for instance, you need a 75 feet cable, but a pre-built 75 cable is not available, or it could be like $150. But you could charge them right away $100 and could create a cable for them. It could be a 65-meter cable as well, or 65 feet cable. So depending on the size, model, how they would need, you could do this stuff. So not for everyone, but maybe you get encounter with it. Plus it looks good to put this on resume. Most likely they would not ask you to make a cable, but at least you would tell them that I did have played with these tools. And these are not expensive tools. Same as with cable stripper. This is another handheld device that also looks like pliers. Its purpose is to remove the protective cover coating from cables. So the top layer, even for this cable, I would not use plier to cut this, because if I use plier, it would cut the inside cable as well. But what I would do is that I'll put this yellow piece into that unit and I'll just rotate it. So when it's rotated, I could easily take out this plastic coating out. Plus it looks good. For second, it's safe. Third, if I'll be using it, I would most probably hurt myself because I'm not that handy with these tools. So again, I believe it's like $5-7. I was checking.
And cut it so neatly.
Yes, it is neat. Any further question? Just go on Google, search for these things, and this is a very important thing. Wi-Fi analyzer. Imagine you have a job or a side gig. It could be in your community. They say that they are having poor Wi-Fi performance at home. You could run this Wi-Fi analyzer and give back them the results that this looks like this. Yeah, if you'll go with the wireless solution, yeah, it would be great or not that great, or it would be below average or just average. So you could give those results back to them as well. One option that you could do that, okay, the Wi-Fi analyzer runs this. There is no interference that I could have find out in your home. Yes, you could have a wireless solution. Just use wireless extenders, like a Nero solution. But for some houses, and I don't know why it's happening, I do have a new construction house. In new construction, I have tried to use these things, and there were some performance degradations that I have seen. It could be the materials that they have used. It could be something else that is causing the performance to get low for Wi-Fi throughput. That is why I am looking for someone who could do this physical piece in my house and could extend these cables in my loft area, where my beloved PlayStation is. So, just imagine what could be the opportunities that you could use. Again, you could quote anyone. You just have to buy this Wi-Fi analyzer tool for like $50 or like $100. You could give them like a free consultation, like if they'll do a job with you. You could charge them like $50 or $100 to all analyze. And you do not have to do anything. Everything is in this tool. You just have to put some numbers onto it, and it gives you the temperature. When you put in those numbers and everything into it, it does generate a report. You could send this report to that person. You could just send it to yourself, compile this in a fancy way, make a slide or PowerPoint. And whenever who sees this, he will say that this person has done an amazing thing and an amazing job. And maybe because just of that report, whatever the tool has done already, we're just representing this in a representable form, and you'll get your business as well. I believe this network fundamental class have turned into an entrepreneurial class or entrepreneurship, but that is also the goal of this course.
There is one website on the internet, I mean a Wi-Fi check something, a network check something. How is that?
I have not checked it, but later on we'll see it. It's a news for me. I have not used it.
Meanwhile, while I'm going over there, so I check on the network, check something, so they'll pop up on the screen.
I'll see it and I'll let you know. Yeah, or after this class, let's do some testing. That
So
would be-
like, how would that be taken? Because most people would want to check the internet speed, like, small.
Yeah, the Wi-Fi speed can be tested. Like if I want to test like what is my IP speed or like speedtest.com, that could be done. But how someone could test this space, I don't fully understand that piece. Like if I run that speed test, would this be able to give me that corner is a dead spot, there is no Wi-Fi signal going to be there. This is a good Wi-Fi spot, that one is not good. That is not what I know. If that website does, then it's good.
Sorry, that is what the Wi-Fi analyzer is going to do.
Yes. So you'll take this, and it's very fun, interesting thing. Like probably I should not say it, but just go buy it, use it, retire it, and get familiar with these equipments if you want to.
Maybe our libraries have it.
Maybe go to your library. You would have these tools if they are given to you. So this could be used, and even you could find your own dead spots in your house as well. So this is something that you could use. Like now it's up to limit that whatever you could do with this.
It's a wireless device, right?
Yes. It is a wireless device. There are some pieces that you could even connect as wired as well. But this will basically analyze your environment, whichever existing environment you have.
This device is useful for me.
Sorry?
This device is useful for me.
Yeah. You could use this. For sure.
Average price.
I don't exactly recall. I used the one that was in my office. I hadn't had to pay anything. I was the owner for this, so I don't know. But I would suggest take the most fanciest one if you're doing business, because that would lure more business into it. And but you may not have to buy the most fanciest one at your first job. Get someone like what we say, like take some jobs, dirty your hands with it, and then buy the fancy. Start with small job, with mine job. Fix up my issue. Okay. So, okay. Any question on Wi-Fi analyzer? Toner Pro. So this is also a very interesting one. Imagine I do have a switch where I do have hundreds of ports, and we have already seen that. So with that device, where it has hundreds of ports connected onto it, how I would know that, okay, one end of this device is connected to another end? So what I can do is that I'll go and connect this cable of other end on one side, and on the other hand side, I'll just manually search for it. So as soon as I go onto the port, it will give me error. It will blink.
For some electrical things as well, like
Yes,
right?
it will blink,
And stuff.
it will give error, it will detect you. So by that you would know exactly that, okay, the other end of the device is connected.
I've seen it at work, they were having issues finding ports, so they like went around like looking for.
Yes, so this is a Toner Pro. Almost on every office you will find this. You may not have a Wi-Fi analyzer, but if you have wired connectivity in your office, most likely you would have Toner Pro. And it's very easy to use. Again, go on and search, you'll find how to use this. It's a very easy to use tool. Okay. What I have also seen with Toner Probe as well, you could also detect, there are some devices you could also detect that, okay, this is where there is electrical circulation there. So most likely we do not have to use this path because it would disrupt the power. Let's reroute it from somewhere else. Or maybe if it's that space, take cable from here, make it down, go from here, and then take it above from here. That could also be a possibility you could use with some fanciest tools as well. And by the way, there is a toolkit which I have also seen. So you could buy that toolkit, and that toolkit have all of these instrumental tools in it. We just have to like do some research on it. Punch down tool, punch down tool is like what Vazi was also mentioning, that you do have a wired cable with you, like the twisted pair cable. You have untwisted it and you have punched this down into the patch panel. That is how you do this stuff. Again, you might have seen this one. Do a couple of videos and see that. Cable tester, same thing as probe, but this one is like to check performance of the cable. So if I do have a cable, one end of that device connects onto the one side of it, the other end connects onto this device, or there could be the two devices depending on the model, and you could do a performance test as well. For instance, there are the device is like 100 feet, the cable is like 100 feet. You should expect 1 gig speed on it, but there is no 1 gig speed. With this tool, you could literally test that how the cable performance is, and based on that, you could have some results, and on those results, you could drag that either the cable is faulty or there is like an interference that is happening. Any question? That's it. This
The
goes
tools
to
part was this.
sorry.
The tools part was this.
Yeah. I wish I would have started from the tools part because it has business models associated with it.
So because I have seen all of those, almost all of those things, like those
Interesting.
crimpers and all, and I have used them with my dad too. So-
Oh, interesting. That's interesting. Any questions? If not, I'll close the recording.